ax squared. Find the value of a if f of x is continuous at x equals 3. If f of x is continuous at x equals 3, then that means that the limit from both sides are equal. So they're telling us that the limit as x approaches 1, that's 3. They're telling us that the limit as x approaches 3 of ax plus 2 must be equal to the limit as x approaches 3, because the limits on both sides are equal. Left hand limit is equal to right hand limit. And so the limit must also be equal to ax squared. So when you plug in the 3 now, you're going to get 3a plus 2. 3a plus 2 is equal to, plugging in 3 now, you're going to get 3 squared is 9. So you get 9a. I will bring over the 3a to get 2 is 6a. And since 2 is equal to 6a, you divide by 6 and so a must equal to 1 over 3. Alright, so that's the value of a. Alright, so hence a is equal to 1 over 3. A is equal to 1 over 3 for f to be continuous. For f to be continuous, a is equal to 1 over 3. Nice and easy. Part 2. Part 2 says, let g of x be x squared plus 2 over bx squared plus x plus 4. And it says, given that the limit as x approaches 1 of 2g of x is equal to the limit as x approaches 0 of g of x, find the value of b. Alright, so let's do that. So part 2. Alright, given that the limit as x approaches 1 of 2g of x, and that is equal to the limit as x approaches 0 of g of x, find the values of a and b. Now, looking at the function, looking at g of x is x squared plus 2 over bx squared plus x plus 4. So we're going to apply x as 1 first. When you apply x as 1, you're going to get 2 times in the, putting x as 1, you're going to get 2 times 1 squared plus 2 is 3. So 2 times 3 over 1 squared times b is b plus 1 plus 5. So that's 3 over b plus 5. And that's equal to, plug it in 0, you're going to get 2 over, plugging in 0, you get 0, you get a half here. When you plug in 0, you get a half on this side. So now we just need to transpose for b. So from this, the 2's cancel on both sides. I'm going to cancel this 2 here. I'm going to cancel this 2 here. Then I'm going to cross multiply. I'm going to cross multiply to get that. Cross multiplying, I get that 4 times 3 is 12. And so 12 is equal to b plus 5. And if 12 is equal to b plus 5, then b must be 7. So hence b is equal to 7. That's the value for b. B must equal 7. Nice and easy, soft. No issues right there. Now let's look at part 2. Part 2bi. the limit as, all right, it's not limits anymore, this is differentiation. So part B says y is equal to 1 over root x. So it tells us that y is equal to 1 over the root x. And it says using differentiation from first principle, find dy by dx. So first thing you have to remember from first principle, that dy by dx using first principle is equal to 1 over h times the limit as h tends to 0 of 1 over h times the limit as h tends to 0 of f of x plus h minus f of x. This is the formula to find dy by dx. It's f of x plus h minus f of x. All right, and so what we're going to get then is dy by dx is equal to 1 over h times, you just need to plug in now f of x plus h. Plugging in x plus h in here, you're going to get 1 over the square root of 1 over the square root of x plus h minus f of x, and f of x is just 1 over root x. That's dy by dx, all right? Oh, I forgot to put in my limit. It's 1 over h times the limit as h tends to 0 of this. Oh gosh, I forgot my limit. 1 over h times the limit as h tends to 0 of this. Let's see how we're gonna simplify this now. To simplify this, first we have to join it as one fraction. All right, so join it as one fraction to say dy by dx is now 1 over h times the limit as h tends to 0, limit as h tends to 0 of the limit as h tends to 0 of, multiply up this to get root x minus the root of x plus h and that's over root x times root x plus h. All right, so this is what we have now. Now when you get to this stage now, you can tackle it in two ways now, but the shorter approach is going to be to multiply by the conjugate of the numerator. So now we're going to multiply by the conjugate of the numerator. So dy by dx is going to become 1 over h times the limit as h tends to 0 of, let's plug in, let's work out that now. Let's write it out first. There's no need to skip any steps. So I write root x minus the root of x plus h over root x times root x plus h over root x times the root of x plus h and that is multiplied by the root of x plus the root of x plus h. So multiplied by the conjugate. And anything you do to the numerator, you have to do it to the denominator. You have to multiply the denominator also by the root of x plus the root of x plus h. Anything you do to the numerator, you have to do to the denominator. All right, nice and easy, soft. Now that we're multiplying by the conjugate, in the numerator, it's going to become 1 over h times the limit as h tends to 0 of, now in the numerator becomes the difference of 2 squared. So it's going to simplify out to just be root x times root x is x. It's going to be a squared minus x plus h. So it is x minus x plus h over root x times the root of x plus h, root x minus the root of x plus h times root x plus root x plus h. Now the thing is, we're always trying to cancel this h right here. To cancel this h right here, what you realize is that this part in the numerator is going to simplify out to just be x minus x cancel. So in the numerator works out to just be minus h. All right. Now we always want to cancel this h. This 1 over h, this h out here cancels this h. So you end up just left back with minus 1 over this. Now when you cancel out this h, now you can apply h being 0. And so it works out to be minus 1 over, plugging in 0 now, root x times root x is just root x times root x is x. So you get minus 1 over x times, plug in h as 0 here, root x plus root x is 2 root x. This is 2 root x. All right, nice. So this works out to be minus 1 over 2x root x. Nice and easy. So that's dy by dx. This is the answer. 2x root x. That's dy by dx. All right. Now, if you don't believe your answer, you can always check it. That's the beauty about first principle. You can know when you're right. You don't need an examiner or your lecturer or your teacher or wherever you do math. You don't need anybody to tell you if you're right, because you can differentiate it to say if y is equal to 1 over root x, in reality, y is x to the minus half. If I am differentiating x to the minus half, then I would get that dy by dx, in reality, dy by dx would be carried down the power, which is minus a half, subtract 1 from the power, which is x to the minus 3 over 2. And so what you'd realize is that dy by dx, x to the minus 3 over 2, is actually minus 1 over 2 times x cubed all square rooted. That's dy by dx, but this can be simplified to be minus 1 over the square root of x cubed. You can write that as 2 times the square root of x squared times the square root of x. And then the square root of x squared is just x. And so you still get that dy by dx is minus 1 over 2x root x. So this is just confirmation that our answer is correct. This is confirmation. This is just confirmation. Confirmation. Just confirmation. All right, nice and easy. Now the second part of the question says, it says if y is equal to x over the square root of 1 plus x, determine an expression for dy by dx. So